Good morning, I'm John Abbott, president of WGBH, and I would like to welcome you and thank you for coming out today. We're very excited for a vivid day of presentations and discussions. We know that your time is one of the most precious resources that you have, and we hope that you will enjoy our annual Innovation IdeaLab, a festival of ideas that comes to us thanks to the generosity of the Candida Fund, and I want to thank them right now. The IdeaLab is a time for us to look for new ideas for public media reporting and storytelling, for grappling with what we are often called wicked problems, problems that are hard to solve, and to hear from some powerful visionaries and doers about positive approaches for solving them. Gathered here are our top WGBH editorial leaders, researchers, and reporters, leaders of Frontline, American Experience, Nova, Studio 6, World Channel, and our new program, Third Rail with Ozzy, PRI's The World, Innovation Hub, and WGBH Radio, producers of children's programming and educational media, as well as independent producers of public media from our extended family. We also have WGBH board members, foundation representatives, and friends and wonderful supporters of public media to be part of our day together. In short, you are a room full of very talented and engaged people. So I hope you'll take the opportunity during the breaks and lunch to introduce yourselves to one another. I think you'll be glad you did. We're also showcasing some of our work in the virtual reality realm. You'll hear more about that this afternoon, but please check it out in the Calderwood studio, which is adjacent to the atrium just outside. Over the last year, the world has been changing rapidly, and not just politically. Almost every 2 weeks, we've been buffeted by major events and whipsawed by new challenges, from hurricanes, flooding, and wildfires, to concerns about nuclear security, terrorism, attacks on the media, and the rise of ethnic and religious prejudice. We've seen a lack of civility and many challenges to our core values as a society and as communities. Deeply embedded in WGBH's mission lies the commitment to helping our audiences understand and cope with dramatically new trends. So we at WGBH feel more than ever the responsibility to create programming that offers a diversity of prisms and perspectives reflecting a changing nation and world. And key to that is listening to new voices and new communities. It's said that nothing is more difficult than to predict the future. Of course, that's supposed to be a joke. But in fact, we have some powerful thought leaders and frontline makers here today who will give us the benefit of their ideas and approaches so that we can address the future with greater confidence and creativity. We hope you'll leave feeling newly stimulated and inspired by what's coming over the hill. And now, I'm grateful to turn it over to our first moderator, the inimitable Miles O'Brien. Welcome.
Thank you, John. I appreciate that. Welcome to the seventh annual IdeaLab. This is my fall reset from when you get a little blue, you come to IdeaLab and you think there are some smart people out there with some great ideas. It's tough to not be pessimistic, frankly, these days. I would say that the tone right now in the world matches the weather this morning. I read this morning of a group of 15,000 scientists from 184 countries offering a second warning to us all that humanity has failed to make sufficient progress in generally solving foreseen environmental challenges, and alarmingly, most of them are getting far worse. Happy news on a Tuesday morning. But there are a lot of people we're going to be hearing from today who actually can give us a little bit of optimism, because there are some good ideas out there. Of course, the key is turning ideas into action. And our role in that as producers and writers and directors is to give these ideas a greater audience with the hope that those ideas do, in fact, turn into action. I am also thinking this morning about the late, great Gwen Ifill, my colleague at PBS NewsHour, who we lost 1 year ago, who cared very deeply about what we're talking about sharing stories as a way to affect greater change. But there is some optimism. Our first speaker, Janine, I was reading some of her work just this morning, and you're gonna hear a little bit more from her, of course, in just a moment, but this one really gave me some hope. She said, if you look at things, it may very well be the storm before the calm. A system that is far from stable is a system that is ripe for change. So let's try to latch onto that thought as we listen to all these great ideas all day today. I, for one, am looking forward to it. Yeah, most of you are familiar, but for those who haven't been to one of these, what we do is we do 3 speakers per session. We give a few minutes for them to give their presentation sequentially. Then they all sit down, and we grill them and audition them for potential roles in Novas or Frontlines or PBS NewsHour. As a matter of fact, Janine is sitting for an interview with me at noon today for the PBS NewsHour. So we're already taking full advantage of your presence here. We appreciate it. And we look forward to some stimulating thought and some creative ideas that will come out of this. So I'm not going to spend a lot of time reading bios. I think that's kind of a waste of time. You have that all in front of you, or you can Google it if you like. We will just listen to them, absorb the ideas, and then we'll do some Q&A afterwards, and maybe this will lead to some great ways of telling some good stories. So without further ado, let's bring up Janine Benyus.
Thank you. Last night, Harvey mentioned the importance of respect as sort of a cornerstone for conservation, and I could not agree more that how we see nature will determine the future of nature. This is a gecko at the University of Akron, where they're studying geckos to figure out how to do dry adhesives and Superman-type crawling up walls. This gecko is named Catherine the Great. True story. My degrees are in forest science, applied biology, and when I went to school, I learned about these systems I learned to look at them as basically how many board feet are there. How many baseball bats can we make out of the ashes, right? Out of the ash trees. It was a very particular way of looking at these systems. Now when I look at them, I see, the most amazing solar panel array that we could possibly imagine, made out of ubiquitous local materials. I see millions of chemical reactions going on silently, non-toxically in water. I see miracle materials being made, composites, long before we were onto it. I see the answer to how to clean water. Water leaving a forest has very, very little that the forest doesn't need. It is absorbed. It's called nutrients. Circular economy is what I see now. I don't see board feet anymore. I see a distribution network paralleled to none for gases, for water, even for electrons. I see this is a Seven Sisters oak, one of the 740 that did not die on Charles Street, because I see hurricane resilience built into every inch of this spiraling, flexing tree. I see a system that can replicate itself. Talk about information technologies. And I also see that a sustainable world already exists, and that's what biomimicry is catching on to. I think that asking what would nature do here, what wouldn't nature do here, why and why not, seeing nature as a teacher rather than a warehouse of goods, is the future of how we're going to relate to the natural world. So quiz yourself on what you see, and let me tell you a little bit about the biomimics and how they see. So when you see this, you see a school of fish. Very interesting. When John DeBerry saw a school of fish, this is what he thinks. He learns that the fish in the front throw off these little spirals, these vortices into the water. The fish behind them curve their bodies and surf upstream that way. So he created a wind farm, a vertical axis wind farm, in which when the first wind turbines start spinning, the ones behind them spin before the wind even hits them. It's 5 times the power of a horizontal axis wind turbine, just by putting them in the right formation. Nothing new invented here, just rearranging the mental models. So it's a conscious emulation. There's 3.8 billion years of R&D. This is, those are the denticles on the side of a shark. It's part of how it plays with drag in the water to make it go so incredibly fast. It's also, on the Galapagos shark, how it keeps itself free of bacteria, not through chemistry, but through a physical substance. This is now the mimic of that, sharklet technologies, a new way of dealing with antibacterials that doesn't breed for resistance because it's not chemical. So biomimicry is not using wood to make your flooring. It's not bioutilization. It's not using algae to come up with diesel. It's not bio-assisted technologies. It's quite different. It's not domesticating or extracting. It's valuing nature for what we can learn, which I would submit is a very, very different way of relating to the natural world. Learning from nature is a whole different set of scientific questions than learning about nature, which we've been doing for a very, very long time. So it begins with noticing what works. You know, Gregory Bateson said there's 3 orders of change. The first order of change is to do things better. The second is to do better things. But the third and the most powerful is to see things differently. So, coral reef, right? You can see it from space. This is Brent Constance. What he saw, what he learned, the key thing that turned his life around is, and he's a coral researcher, realizing that corals sequester a ton of carbon dioxide for every ton of reef, which is a concrete-like structure. He said, why don't we do that? Right? So Blue Planet, Calera are both companies he started. He takes CO2 out of smokestacks, combines it with seawater or brine from desalination plants, and out precipitates the raw material for aggregate, for concrete, for our largest or most building material in the world. So is it a feedstock or a pollutant? The way nature sees it, it's a feedstock, right? So now we're starting to have people like New Light Technologies and Novomer who have studied the plant enzyme, the protein rubisco, to come up with a new way of taking CO2 and turning it into plastics and fuels. Take methane and turn it into plastics. IKEA is going to be making all of their furniture out of methane coming up. So what do you see here? It's a system, right? It's a kelp forest. This is really an interesting one. 3D ocean farming, 3D permaculture is a new kind of aquaculture that does not, put fish in cages in the ocean. It actually recreates a system that gives you shellfish as well as kelp. And together, those are all agricultural products. The fishermen are now farming these areas, but the shellfish absorb the nutrients. The nitrogen and the phosphorus is absorbed by the kelp, which is growing 5 times faster, absorbing 5 times more carbon dioxide than terrestrial plants. Right? So what you wind up having, this is Bren Smith, these are mimicking a system in this case, not a product. You're able to actually look at restoring the ocean. It actually reduces ocean acidity while growing food, while pulling down carbon dioxide, while having chefs maybe give us some new cuisine, right? So what do you see here? Mangrove, right. They're taking salt water and making it into fresh water with solar power, right? And they're doing that because there's these aquaporins. They're all over your blood cells too, by the way. Hourglass-shaped pores that pull water molecules through rather than pushing against the membrane like reverse osmosis, which clogs it, which takes a lot of energy. The pores themselves pull the water molecules through. It's called forward osmosis. First company is in Denmark, but you're going to see a lot of this forward osmosis based on aquaporins, these pores. It's 1/10 the energy, very, very low energy desalination. And you see a bird like this, who knows what this is? Kingfisher, right, right. And when they enter water, look at that, there's no splash. Perfectly shaped beak. The engineer for the high-speed train that used to be called the bullet train, because it went, and he was asked by his boss to quiet that train, because when it goes through tunnels, because it was rounded in the front, it would build up a pressure wave, which would create a sonic boom on its exit. So he literally went to an Audubon-type meeting one night and saw these guys diving and said, from one density of medium to another, I wonder if it would scale, and it did. 15% less electricity too, and 10% quieter. It's about looking at things very, very, very differently. So there's teams all over the world doing artificial photosynthesis work, which is not sunlight to electricity, it's photons to fuel. Life takes sunlight and turns it into stuff, into chemistry. So lots of people working on this. And then you look closer. As you look closer, what do you see? Look at the bumpy structure. There's a scientist in Tokyo that decided to basically wrinkle a thin film solar cell and got 47% improvement in solar cell efficiency. Lots more surface area. Right? So biomimicry is about viewing and valuing nature in a whole new light. Right? This is a bobtail squid. I used to look at it and think one of the most endangered species on the planet. I think that now, and I think, oh my God, that's who has taught us what we now know about how to deal with bacterial biofilms. Because in its light sockets, in its eye sockets, there are bacteria that are luminescent. But they're not luminescent until they get together, communicate enough to be able to turn on their light. And those communication languages are what we're learning from this guy. This is a humpback whale, Frank Fish, true name, true story, couldn't make that up. When you put tubercles on an airplane wing, it reduces the drag by 32%. That's a school bus-sized organism that has to do ballet in the water in order to feed. Here's a Namibian beetle. No groundwater in the Namib Desert, lifts those scale covers above its wings there, and they're particularly shaped to be able to comb moisture out of fog 10 times better than our fog catching nets. 10 times better. Just a little shape and chemistry. So this is a Boston boy who started NBD Nano, and they basically are now a very, very successful company that just got 12.6 million. They're doing coatings for condensers to move water around based on this. He started out in a design contest doing a self-filling water bottle with getting filled by humidity. And now they're doing coatings for all kinds of industrial pipes and whatnot. Do you know what this is? Yes, this is, you nerds. There's a bunch of nerds in this audience, my God. Tardigrade really up close, really, really a tough organism. Can dry out almost completely without dying. It wraps its organs in this stuff called trehalose. It turns to a glass. It's kind of an amber. It's a sugar, but it turns to a glass like amber. and it protects the organs. So this is Ralph Mueller, and he actually, brine shrimp, these are brine shrimp. Remember sea monkeys? Ah, of course, in this audience, you're still playing with them. Anyway, he got it, it's cryptobiosis, the same phenomenon in sea monkeys. And actually, he's created, that's Biomatrica in San Diego. He's created a way to shrink wrap biologicals like blood and proteins. Imagine his goal is to unplug every freezer in every lab and hospital in the world. They're also creating vaccines that are shelf stable, that do not need refrigeration. So even the little critters can teach us a lot. Kelp, this is Jay Hartmann. He noticed when he was 8 that he couldn't pull up kelp, even though there were enormous tides that were taking it in one direction or the other, and it was never ripping up. He was able to pull it up, and he said, what's going on here? Notice that it was the shape of how the kelp would curl itself into a Fibonacci sequence, a flow structure that would allow water to go through. He now makes impellers, fans. This is one that mixes municipal water with basically like the electricity of 2 light bulbs. So there's little tiny companies, like I told you about, little startups. There's also enormous amount of biomimicry now going on in the innovation labs here. I also have, in addition to BioMimicry Institute, I have a consultancy, and we work with companies like this. So you can see across the spectrum, this is what's going on. This is the number of patents. There's something called a Da Vinci Index that looks at this. Products are basically doubling every 2 years. And papers are, they're doubling every 2 to 3 years against a background rate of most sciences. The papers are doubling every 13 years. So it's just bio-inspired work, and it's everywhere. I mean, the Bionic Chip is a neural network-based chip, right, based on your brain. So it's everywhere. And it's in the zeitgeist. You'll see it. I mean, I'm sure there's possible media that have covered this in the past. There's all kinds of, Harvard Business Review, Fortune, the things that people are saying now about this. Fortune's just saying it's the top 5 trends to ride in 2017. What's going on here? What we decided as a nonprofit, and thank you, Candida, Diane Ives is here, has supported us since the beginning, actually, and Beth Ratner. Beth is my executive director of the BioMimicry Institute, so please talk to her. When we decided how do we democratize this? Does it stay in corporate America? I hope so. Does it go everywhere? I hope so. We decided to do a challenge, a design challenge. We have, it's global. We have thousands of participants from all over the world. Half of them are girls and women, which is really important, I think. McKinsey said in 2009 out of all the prizes, 30,000 prizes at that time, only 219 of them were over 100,000, and only 29 were about the environment. And we were the only one that was bio-inspired. So when you look at this, and by the way, that's what's inside. Nobody knows that. Very few people know the Nautilus. We had students who said, why don't you, the air ballast that allows that thing to go up and down the water column, why don't you do an air ballast instead of a water ballast in ships so that you don't have invasives? Really good idea, right? They found that, this was our water challenge, they found that leaks were causing, in Europe alone, 22% of the water is lost through leaky pipes. And a lot of it happens because air bubbles get so large that they break they cause a lot of pressure inside the pipes. So they said, I know something that gets oxygen out of air very well. So they looked at gills, and they created an inset inside the pipe to bleed water, to bleed air out of water so it wouldn't build up. Really smart. We then said, my God, these are so good. Can we add some entrepreneurship to this? So now there's a $100,000 prize for our work with like a mini MBA you get with it as well. So we're on food systems now. We just finished food systems. This was one of the teams that really interested me. Talk about thinking differently. They looked at the problem of soil degradation. They said, how do you heal soil? And they looked at this really outrageous, it's called a cushion plant, which is basically thousands of plants together. They're in stress up at the top of the Chilean mountains, and so they facilitate each other. So they said, why don't we take degraded land and plant plants that together will restore the soil. So rather than weeding out plants when you plant plants that are helpers. Right? Very, very interesting. So they're creating this thing called BioPatch, and they were the winners that year. We had ones that looked at pitcher plants. This is the one that, the insects go down, but they can't go back up. This was a team that was from high school. And they said to us, hey, a lot of people around the world eat insects. There's a lot of protein in insects. But why don't we help people catch insects? So they did these beautiful things that have the downward pointing hairs catching insects. You can hang that outside your home. This is this year's. It's a way to. It's based on spiders and it's based on all these critters, and it's a way to actually capture rain, fog, store it, and distribute it to different urban agriculture. Really, really interesting stuff. So in addition to training people through our design challenges on how to do this, we also said, even if you're not in our design challenge, how can you consult nature at the moment of creation, right? So we've created something called Ask Nature. Please check this out. It's really kind of cool. It's the Human Genome Project. We're trying to digitize biological information by function, because it isn't anywhere. You can't go anywhere and ask, how does nature manage temperature or move silently through air? And now you can. We have a huge taxonomy of verbs. We had to come up with all the verbs of all the human endeavor in the world. Right? And you can check. It's really fun. I wish I had had this when I was a kid. You can type in basically a function like ventilation, and you can see all kinds of different biological strategies and also case studies. So that's a place to go for media to understand really what's going on in the field. We would like to see this to be the Google, basically, of nature's solutions. So we want to digitize. We want, that engineer who had the beak, the Kingfisher's beak. We want inventors now to be able to download that and put it right into their CAD programs, right? So we want to do scan jams in which we're gathering those drawers of natural history museums and scanning all of those things and putting 3D models in, being able to take the structure inside the lantern of a firefly. It increases. They've put that structure on the inside of LED lights and increased the brightness by 55%. Imagine if you could download that shape, or download these water repellent shapes or anti-reflective shapes right into when you're designing something. That's what we're hoping. Or generative design for the new additive manufacturing, as manufacturing becomes digital. We might as well have nature's ideas right there. There's a concentrated solar power that uses the packing strategy of the inside of a sunflower, 20% more mirrors on the same land. Or bone-inspired algorithms. I think your products are going to start to look more and more like this. So this is what, a sage on a stage said once, right? And I don't know whether he was talking about synthetic biology or genetically engineering organisms. That's not what I'm talking about. I'm not talking about making new organisms. I'm talking about understanding the ones that we already are surrounded by, okay? And seeing them as teachers instead of as a warehouse. We're one of them too, right? And we're pretty cool, actually. I get into a rhetorical box here. We are nature, which is why biomimicry works, actually. We're very, very young, only 300,000 years old, but we live on a competent planet. And that is the message, really, to tell young people today, that we have competent elders. This is what I tell young people these days. Thank you very much.
Janine, I need you up here for 1 second while they get the PowerPoint together.
Okay.
I have one question for you. Why has it taken us so long to figure this out, and why is this happening now finally? Is there some technological intersection that is making this happen, or are we just finally waking up to this?
Yeah, you know, I think it's a push and a pull kind of thing. I don't know why it's taken so long. For Western industrial culture, I think that probably indigenous people admired organisms in their habitat and went, wow, you know, there's a snowshoe floating on the snow. Maybe I'll make snowshoe. You know, people did this before. Why are we doing it now? I think the unintended consequences of what we've done is sort of showing up now, right? And at the same time, we've got, we're able to see nature like we never have before and understand. So in part, it's our senses have gotten so good, you know, with instrumentation and science. We're just at a point historically now where we're starting to understand how nature works or miracles.
All right, thank you, Janine. More from you later. Let's move now to a man who describes himself as a recovering weather forecaster. Is that it? A retired Navy Admiral, and a man who was once a climate change skeptic and ultimately ran climate change adaptation programs for the Navy. So there's a lot there to talk about. Dave Titley.
Okay, thanks very much, Miles.
Yep.
So thanks again. Thanks very much for having me here today at WGBH. I really appreciate that. Miles brought up a lot of things there, which actually are not in the talk, but if we want to discuss some of these in Q&A, I'll be happy to do so. So really, what I'm going to talk about here is why climate and climate change is important from a security aspect, and really, it gets into three things, and I find I can only remember three things. Just as an aside, the Navy has this exquisite maritime strategy. It was developed up at Newport by the War College, the smartest people. They have all kinds of things. It was tested, and they have like 6 tenets of it. So when I was an admiral, because I just do this sort of thing, I would go up to my fellow admirals, basically the people who are supposed to be running the Navy, and says, here, quick, name the 6 tenets of our maritime strategy. Nobody could do that. So I stick to 3s because I can remember 3s. And climate, let's face it, climate can be overwhelming. There is just so much stuff. One of the things I find when I talk to people is it's really easy to get overwhelmed. So what I talk about on climate really is 3 things: are people and water and change. And really, the people is because it's about us. And while there are tremendous environmental concerns, I'm not sure that those concerns have frankly moved us people, to any kind of action yet. But the climate, what I try to get across to people is that climate is not just going to impact some far-off polar bear in some far-off northern climate, but it is impacting all of us, you and me, our sons and our daughters, our moms and our dads, our neighbors, in our towns, in our cities, in our country. It affects everybody. It affects us today. It's going to affect us tomorrow. I talk about water. I found that water is a pretty good organizing principle for many of the actual impacts we're going to have from climate. As we increase the heat, basically, of the system, which is what we're doing, we change the hydrologic cycle, or the water cycle. So we have too much, too little, wrong place, wrong time. The water is salty where it used to be fresh, wet where it used to be dry, liquid where it used to be solid. And if you study the oceans, even the very chemistry of the ocean itself is changing. All of those have security implications, and I'll get to in a second there. And finally, it's the change piece. You know, I'm right now living in central Pennsylvania, just came in here into Boston, a wonderful November kind of day in Boston, right? 42 degrees and rain. So unless you're from, I would argue, San Diego or maybe Hawaii, you don't have ideal climate. But what we have had is a stable climate. For roughly 8,000 to 10,000 years, we've known pretty much what kind of crops would grow, about what the seasons would be. If we built a port, the sea level basically stayed there, so it didn't go up or down. And we have built human civilization implicitly on this premise of climate stability. And now that stability is changing. And honestly, if we were cooling as fast as we were warming, we would have equal issues. So it's not the warmth per se. It's the fact that we're moving away from where we and, frankly, the ecosystems have stabilized at is going to be the issue. So us going up in temperature and sea level is going to be a tremendous issue. So really, it's that change piece. And if anything scares me, it's the change piece. So people, water, change. That's kind of why I tell people that we should really pay attention to this. When we step down into the security aspects, it's really these three. And honestly, we could do about a week seminar on each one of these, but Miles would probably be pretty unhappy if I spend a week on each one of these, so we won't do that. We'll just kind of touch on some of these. So when I talk about the operating environment, this is actually a picture I took up at Svalbard. If anybody has ever been to Svalbard up in Norway, it's about a 2.5-hour flight north going up to, leaving from Oslo. It's this little island off the northeast coast of Greenland at about 80 degrees north, way further north than anything the United States has. Barrow at the north tip of Alaska is roughly 70 degrees north. So this is way up further north. This is not episode 2 of Star Wars. It isn't something like that. But it turns out you're so far north that in Svalbard, one of the things you can do is control every single polar orbiting satellite on every single orbit, just because of the way the satellites are going around the Earth there. So it's very strategic for space. There is also something called the Treaty of Svalbard, and this has actually just been in the news in the last couple of days. If you ask the Norwegians say Svalbard is ours, it's Norwegian territory, end of story, have a great day. But there's the 1920, I believe, Treaty of Svalbard, outgrowth of World War I, that basically says, yes, it's Norwegian, but if you have a research station and you were a signatory, you can be there. So the Russians push on this. And in fact, the Russians, to get their navy out into warm waters, have to go between the northern tip of Norway and Svalbard. And Svalbard is almost Norwegian territory, but because of the treaty, not quite. The European Union, in fact, right now is basically suing the Norwegians to say, hey, we want to go and harvest crabs, snow crab resources inside the waters of Svalbard. And it's like, so what? But remember that Norway is not part of the EU. This would be like just somebody else coming and saying, hey, we want your stuff right near the coast. And the Norwegians have really tried to sort of avoid having this discussion, but it's coming right now. Why does that matter? One, it matters for other resources. And two, things like when the Russians show up, what they have done is they've like taken their deputy prime minister and just sort of dropped him off on Svalbard. You know how the Norwegians found out? The media. They watched it on TV. So they go and ask the Russians, hey guys, like kind of what's going on? And the Russians basically said, deal with it. So you have this very strategic island up in the, that controls the waterways to get to the Arctic or from the Arctic. It's mostly Norwegian. The Norwegians are really good allies of the United States. But if we ever get into some sort of contention on Svalbard, is the United States going to recognize that as truly Norwegian, and therefore you have things like Article 5 in NATO? Or is it not quite Norwegian, and therefore you don't quite have Article 5? How's that going to play out? So here's just one example in the Arctic as we rapidly warm, increasing human activity that people are going to have to think about. In Q&A, if we want to talk about more, we can talk about Greenland. Greenland wants to go independent. Mostly in the United States, that's kind of ignored. Greenland is an island of roughly 50,000 native Greenlanders. I teach at Penn State. That's about the size of the University Park campus, except that's their entire country of Greenlanders. And how is this going to play out? Is it going to be uranium? Is it going to be oil? China is very, very studiously courting Greenland right now. How is all of that going to play out? So lots of wild cards going on in the Arctic as the ice melts out. So rather than talking about sort of the race for resources or the shipping lanes, which I'm sure everybody's heard about here, I wanted to bring up some of these other sort of lesser known kind of geostrategic implications that are going to play out, and I would argue the United States is not really thinking about them right now. Let's talk about some of the infrastructure. Yes, everybody here has probably heard of the sea level rising. This is a map not of sea level rise, but really of about roughly how many people live within about 1 meter or just over 3 feet of high tide. So you can kind of see where the reds are. So places down like Florida here. Basically what I tell people is if you're down there, let me figure out how I can short your real estate because I want to make some money off of it. Because at some point, this is all not worth very much. And we're going to have to figure that out. Sacramento has an issue as well with the levees out here. Those are going to be an issue. But from a security point of view, let me point out around the Norfolk, Virginia, or what we call the Hampton Roads area, just up and down here. So the next slide is going to kind of zoom into here. So here's Norfolk, here's Virginia Beach, and this is what, with 1 degree Celsius, and we're already there, when we stabilize the ice sheets, the best guess is that we're roughly 7 feet of sea level. Now this yellow circle you'll see on the next couple charts, that's where the naval base itself is. And when you go to Norfolk, and in fact, I was just talking to some NOAA NOVA producers, and they said, you know, they were down here just a couple of weeks ago. You know, they'll show that the piers are slightly higher, and the Navy says, don't worry about this, we have this under control. And maybe for 1 degree you do. But as you go to 2 degrees, and you have 15 feet, or 4 degrees and 30 feet, and that's probably, we're somewhere between a 2 and 4 degree world unless we do amazing things. I kind of say, dudes, you know, it's interesting that you're raising the pier by a foot, but I hate to tell you, but the coastline's back to Yorktown. So, you know, this idea of what are you going to do about the piers, it's really the wrong idea. It's what are you going to do about Norfolk and Virginia Beach, because they're not here anymore. And people aren't really thinking about this. They want to think in terms of 6 inches or a foot or 2 feet, but that's about really all that we're doing. And it's very, very hard for the Department of Defense to do the kind of planning for this different world, this very different world that we are going to go into. I was talking to the senior person in the Office of the Secretary of Defense about this a couple of weeks ago, and they said, you know, we just can't even go there. And it's like, well, somebody's going to have to, because unless we get amazingly serious about reining in the climate change and the greenhouse gases very soon, these are the kind of worlds that we're going to be dealing with here. Okay, for the Department of Defense, there's a couple other places, in addition to, you know, thinking of our bases in the United States. And it really is kind of a Navy thing. You know, we're not the Air Force. I can't just pick up everything and move to Minot, North Dakota at 5,000 feet above sea level. Although I said that one time, and sure enough, in the back of the audience, the city manager from Minot, North Dakota was there. True story. And he said he'd love the Navy to be in Minot. I said, I really, sir, I did appreciate the offer, but I'm not sure that we can figure out how to make it happen. It's a ship thing. We tend to want to be in the water. I don't know why. Okay, couple other places. On the left is Diego Garcia. This may be perhaps the most strategic island that nobody's ever heard of. It is in the Indian Ocean, just south of the equator, southwest of India. Tiny little speck. It's actually owned by the Brits. And as long as the Department of Defense is nice to the birds and fishes and turtles, we in the Department of Defense can do just about anything we want there. It has supported every significant Department of Defense operation in Southwest Asia for the last 40 or 50 years. It's also 1 to 2 meters above sea level on a good day. I spent a week in Diego Garcia one day, and it's, you know, when this goes, and I've asked the Department of Defense, so tell me what the effective rate of sea level rise is here, and tell me what happens when we lose it. And almost without exception, somebody looks at their watch and realizes they have an urgent meeting they need to get to, and invite me to leave the office because we don't have a good plan B, and we're going to have to figure that out. On the right-hand side here, we had, this is Kwajalein, another island out in the middle of the Pacific. And the Air Force is building a space fence, which is good. This allows us to understand everything that's up in space, orbiting around us, and we want to do that. So part of that space fence are these billion-dollar upward-looking radars, and they're putting one on Kwajalein, 250-page environmental impact report that talked about everything except sea level rise. Why would you want to think about that? So what they've sort of figured out is a 50-year life is now maybe going to be 20 to 30 years at best because of the sea level rise. It would be funny, except it's all of your money because that $1 billion comes from us. It comes from us taxpayers. And if we're not planning and adapting for these things, we're going to be in trouble. Okay, making bad situations worse. I'm just going to go very, very quickly through this. Syria has certainly been talked about in a climate context here. And really the point that I try to make about Syria is climate is one of the links in a very complex chain that gets us to the catastrophe that is Syria. I know many PBS shows and other shows have documented like some of these modern airline crashes, which thank God are very, very rare. But when they happen, it's almost never one thing. It's this whole series of events that come together that lead to a really bad outcome. And that's kind of what happened in Syria and these bad events. I mean, you can actually trace it back to the 1970s. Assad gets in to power, and he says to his advisors, I want to be self-sufficient in wheat and barley. And you would like to think that the advisors would say, you know, boss, we're in the Eastern Mediterranean, kind of a desert, maybe not the best idea you ever had. But I think what happened is they said, sir, you are a smart, powerful, and handsome man, and we'll get right on that. Now, thank God that would never happen in this country. But, and they did. They actually became self-sufficient. But they did it at the cost of draining their aquifers, draining their surface water. So it's kind of like, yes, you have the nice boat and the RV and the driveway, but you have nothing in your checking account. That's kind of what they did. And then some, completely non-climate events. The Iraq War comes across. 1 million Iraqi refugees end up in Syrian cities. It's Assad. He does not take care of his own citizens, let alone refugees. So the tensions build. And then you have a drought that the climate scientists can really show has a lot of attribution for its severity, its intensity, due to the climate change. And the farmers end up with nothing. They just have nothing because they've already used up sort of all that reserve of water. So you now have 750,000 of farmers, internally displaced persons, on top of the 1 million refugees in the cities, and everybody is desperate, and you have the government who is not taking care, in fact, is making things worse. And this then just becomes this breeding ground for al-Qaeda Iraq, al-Qaeda Syria, and ISIS. And we have the catastrophe that we have today out there, all the way from the refugees with 1 million refugees out of Syria, nearly bringing the European Union to its knees, and all of these other unintended and really unforeseen consequences. So yes, climate played a part. It was not the cause, but on the other hand, had we not had this climate-induced drought, we may not have had the same degree of troubles that we have in Syria today. So what to do? First step, it's kind of like the 7-step thing, right? You have to admit you have a problem. Secretary Mattis, to his credit, has basically said that. He has said that in his response to some questions he got at his testimony for confirmation. And nobody can accuse him of parroting the White House line here. So, and he has also tremendous credibility. So that in itself is actually helpful. If we have time, I can tell you why I have a llama here. But basically, llama stands for, and I'm told, some people tell me that's an alpaca. So whoever runs the nature shows here, guys can tell me if it's a llama or an alpaca. And if it's an alpaca, I'm sorry, but I like the llama thing. But basically, learn local action, monitor, and advocacy. And by advocacy, I ask people very, very simply, just ask leaders really at any level, and they can be business or political leaders. It's like, sir or ma'am, what are you doing to stabilize the climate? So it's kind of an open-ended question. It's like dating 101. Don't ask a yes or no question. It allows you to not get trapped into the, oh, well, let me tell you why cap and trade is a bad idea, or, oh, I can't support a tax on carbon because. Just tell me what you're doing to stabilize. You might get a good answer. You might not get a great answer, but somewhere in that reptilian politician brain, it registers that one of their bosses, voters, are interested, and that counts. That counts a lot. And here's an example of how that counts. So the guy on the left is a guy named Jim Langevin, not too far from here. He's the Rhode Island representative, state representative in the House. And he introduced an amendment in the current defense authorization bill that basically said the Department of Defense should really pay attention to climate change and tell us what you're doing. That's basically what it says. Now, this is the same House of Representatives that a year ago said for the Department of Defense, there is nothing to see here in climate change. We have no idea why you're interested, and for God's sake, don't spend any money on it. So fast forward this year, his bill made it through committee. It goes to a floor vote in the House, and believe it or not, passes. And 46 Republicans vote in favor of this. Another 8 realized at that exact moment of that vote, their Starbucks coffee had gotten cold and they had to go out, so they weren't able to cast the vote, so they abstained. Imagine that. So you had over 50, you basically had over 50 Republicans not voting against, pardon the double negative, but not voting against climate change as a security issue. That's a huge change. That's a really, really big change that we lose in all the tweets of the moment and the silliness that we see around this issue. So that's really, really encouraging. And his Langevin's amendment made it through the entire conference process, and now it's in the final bill, which will likely get passed and will likely get signed because it's must-sign legislation. When we looked at where those districts were, it was not if those Republicans had a military district. It was not even if they were on the coast, which is what I thought it would be. It was how purple had their district become on the climate issue. It's all about the politics. So it really all begins with the voters. And as the voters change, Congress will not lead, but they certainly can be led. And we're seeing it happen. Despite all odds, in this administration, it's happening. So let me just close. Let me just, climate can sometimes be somewhat of an abstract kind of thing, and try to make it a little more personal. When I was running the Navy's weather and ocean prediction capabilities, it's down in Mississippi, and this is our house we lived in a little place called Waveland, Mississippi. And if you ever wonder what a 9-meter storm surge does going up your street, that's me, and that's the house. So when we say we lost the house, we really did, because this is what it looked like. So the house is either all the way over there up in the railway tracks, or it's all the way over there in the Gulf of Mexico. We're not quite sure where, but it's gone. Now, the one good thing, I'm sorry for the time, but one good thing is that house here was the ugliest house on the street. So my fantasy is my house came off its foundations and knocked down the really ugly house, and that's okay. So I show this not for sympathy. We were, in many ways, we were the luckiest people on the Mississippi coast for a variety of reasons. But as the seas rise, and you don't even have to make assumptions about how hurricanes are changing, although the evidence is increasingly showing that they will likely be stronger, not weaker. But just as the seas rise, more and more people will be faced with this because it would take a weaker and weaker storm to generate this kind of damage. If we don't have ways to accommodate those people and help them rebuild back, we will have a lot of really unhappy, desperate people, and they lead to a security issue. So I think Admiral Nimitz, who I don't think many people would consider to be a tree hugger, I think had some pretty good words on this. It's like, do not be grudging in taking precautions for this risk, and that's what climate change is. It's a big risk. The risk is here, and we need to buy the risk down. So this gentleman here, Winston Churchill, was alleged to have said that Americans can be counted upon to do the right thing after exhausting every other possibility. And we're still in the process of exhausting here. Hopefully we'll get done with that soon. But I think once we are, we will be in good shape, and we will get focused. America does amazing things when we're focused, but we're not there yet. But we, the people, will get us there. Thank you very much.
One sec, stay there. You know, it occurs to me that human beings, their primary drivers, motivations are fear and greed. And the security connection to climate change, there's the fear component. And that seems to be resonating a little bit. How do we make people realize, because obviously the polar bear on the ice cube is not working, to get people concerned. That's more altruism, which I don't think motivates us as well. What about the economic piece? How is it possible to explain to people that there's a true economic component to this? The insurance industry gets this, but what about average people?
I think this is one of, economics. I would add health as well, because people like to be, nobody likes to be sick. Nobody likes to see ourselves sick or our relatives sick. The economics, and people like Hank Paulson, like Bloomberg, have certainly been working on that, the so-called risky business approach, who I imagine many people in here have seen. I don't know that has, I was going to say trickled down, but I won't say that. But I don't know if that message has really resonated down into the deck plates, except for maybe people who are living by the ocean and are now having a very hard time getting either insurance or are seeing the housing property really start to come down. There are neighborhoods in Norfolk that it is becoming very difficult to sell your house. So I think the economics of this will be one of the drivers. And I think to your point, Miles, is how do you make this to be in people's self-interest and not just I'm doing good for some amorphous good, and that will help us.
All right, thank you very much.
Thank you very much.
Admiral Titley,
Thanks.
appreciate it. All right, so we are going to move now into the issue of habitat loss. And a gentleman who has an organization that's busy preserving a rather significant corridor all the way from Yellowstone up to the Yukon, hoping to reunite northern and southern grizzly bears. And we hope it's not like when the East Coast and West Coast rappers meet, because that's bad. But tell us a little bit more about that, Harvey.
Sure, thank you. Great privilege to be here, and thank you, Linda Harrer, for inviting me. I want to talk to you about an idea called Nature Needs Half and the Yellowstone Yukon Conservation Initiative and our relationship to this place. So this is home. It's the only place in the universe we can live. It's the place we get the air we breathe for free, the water we drink for free, and it's the space we share with the rest of life, all other living things. This is my home on our home. I live under the Yellow Arrow in Banff National Park in Western Canada. It's a place that my family's been for 7 generations. It's still a very wild place. The valley here, the big valley in the left side of the picture, is named after my great-grandfather. And this is a place where we have family memory of abundance in the world. So it's still an abundant ecosystem now. But when my great-grandmother came west, she came up the Missouri River by steamboat to Fort Benton, Montana, to go into southern Alberta and Canada. And this is a painting by Charlie Russell called When the Land Belonged to God. When her steamboat went up that river, it had to stop for 7 hours for a buffalo herd to cross the river in front of her. So my mother knew this woman and heard stories from her. This is not ancient history. And so what happened is we developed a narrative. This is the progress narrative. This is from a handbook about how to go west by an artist named John Gast. And this is Liberty. And she embodies progress. And you can see she's bringing progress from the cities of the East Coast to the west. And as she goes, she carries a telegraph line. The settlers come, the farmers who till the soil, the miners, and she drives out wildness. She drives out the wolves, the indigenous people, and the buffalo. And if you can imagine her being a little grumpier looking and a little more heavy set, that's Queen Victoria. So that happens in Canada and Australia and South Africa and Kenya or wherever you like. So this is the progress narrative of the 19th century that we embraced. But there was another narrative in the 19th century that this part of the world has a lot to do with, and that is the idea that nature was beautiful as a counter-reaction to the Industrial Revolution, the idea of Romanticism. And those two ideas kind of had a tectonic collision at a place called Yellowstone, where the idea of progress in this case consisted in leaving it alone. And thus was created the world's first national park, Yellowstone, in 1872. And that led to a kind of a end of the 19th century reconciliation of the green box on the landscape where we would protect nature, and then we'd have our progress on the rest of the landscape. And we can measure how effective that strategy is 100 years later. The idea of the green box as our nature reserves. And the big ones have been wonderfully successful. So here's Yellowstone Park here, or here's Banff where I live. These are big places. They're bigger than some states. And they have the effect of being good nature reserves. And how we know that is, this is a graphic from La Liberté and Ripple. And by the way, that study that came out today about the World Scientists Warning, that was actually by Bill Ripple, who's one of the authors of this paper. And this is where large mammals were in North America 200 years ago and where they are today. Hot colors means lots of them. 0 means none of them. And what you can see is North America had a lot of large mammals. And this is things like grizzly bears and elk and things with big teeth or big antlers or horns. And you see Buffalo, New York, of course, is called that because it used to have buffalo, right? And you can see that much of North America had a lot of large mammals. And today, the only places where the colors remain hot are out here in the west. And you can see we're down to 0 here. These are the corn belts, the grain belts, where things have been so transformed that nothing can live that's big. Go back one, look at the correlation between the large protected areas and the warm colors. It's a spectacular relationship. This is the same thing would hold in Africa for lions and elephants and so on. So this is the part that's hidden in that. It's the grizzly bear lair. So the hardest things to keep are the large things like grizzly bears. And this is a map of where they were when Liberty set out. This is a map of where they are today in red. So that's Yellowstone. And this is the peninsula of life that runs down through Banff Park, down into Glacier Park in the Bob Marsh Wilderness in Montana. And that's where they were and where they are. But the interesting thing about this map is these coffee beans. That's where they were in 1922. And every single one of those populations has gone extinct since 1922 because an island in a landscape cannot maintain its intactness over time if it's not connected to the processes that are an inherent part of how the thing works. So in Colorado, I gave a talk like this, and down the hall, and it was the last grizzly bear in a glass case, dead in 1959 in Colorado. And it's because there's no way to connect it. And of course, Yellowstone will lose its bears through time if it's not reconnected to this larger peninsula of life running down the Rocky Mountains from Yellowstone to Yukon. And to give you an idea of why that is, this is a Selby Bitterroot area in Idaho, 8 million acres, wasn't big enough to hold on to bears by itself. So we're talking big here. And if you drill into that at a scientific level, this is data from a wonderful study that all these grizzly bear researchers pooled their research to show how many bears there were in a given place, 571 there and so on, almost 1,000 here. But you see these dotted lines? These are actually where it's starting to break up into islands, and that usually corresponds to highways, railways, private land. So the landscape starts to fragment around where humans are concentrated. And the reason we think about bears so much is they're an umbrella species. If you can keep bears in the landscape, you can keep 85% of everything else. So it's not just that bears are cool, it's that bears are cool because they represent nature. That's why they're super cool. So how do you put this all together to move from just the green box to an integrated landscape conservation strategy? And we've been working on this through something called the Yellowstone to Yukon Conservation Initiative, and working with PBS Nova and filmmaker James Brundage, we did a film called Wild Ways Corridors of Life, which explains this a little bit, and I'm about to play a 3-minute segment of it.
Mike Proctor worked with conservationist Harvey Locke to find a way to protect the bear's crossing place.
Research by Dr. Michael Proctor with the Transborder Grizzly Bear Project showed that this rather sad little parcel of land over my shoulder turned out to be the key connector for the motherlode of grizzly bears located in the Wild Purcell Mountains in southern Canada, across this highway, south into the States to the recovering population of grizzly bears in the Cabinet Yaak area of northern Montana.
Protecting this landscape connection has enabled bears to move south from Canada's Purcell Mountains and connect with grizzly populations in Montana and Idaho, which are too small to survive over time. This linkage, called the Kidd Creek Corridor, is one piece of a much larger vision.
When it became clear through conservation biology that these wonderful national parks like Yellowstone and Banff, as great as they were, weren't sufficient unto themselves, that they needed to be connected to each other, we came up with this idea called the Yellowstone to Yukon Conservation Initiative. The idea of making a great corridor up at the Rocky Mountains from Yellowstone all the way into northern Canada near the Arctic Circle.
Yellowstone to Yukon is an ambitious plan to link national parks. These core areas are safe havens where animals can find food, breed, and live without being threatened. Connecting them would recreate the large landscape that existed before humans came.
Now we know that as big as Yellowstone is, it's not big enough on its own. Islands in a landscape become islands of extinction, and the first things to go are the large mammals. The large mammals, the ones that are at the greatest risk of disappearing in the 21st century, the big things like elephants and bison and grizzly bears and lions, require us to practice conservation at an enormous scale.
The plan is to create a 2,000-mile corridor linking Yellowstone to the wilderness areas of central Idaho. This would connect to Glacier National Park and to Waterton Park across the US-Canada border and on to Banff, Canada's premier national park. Farther north, protected areas become bigger and wilder, all the way to the Peel watershed in the Yukon Territory. The point is not to take over private land along this corridor, but to work with landowners and managers of public lands like national forests so that wildlife can safely move through.
So that's the idea of Yellowstone to Yukon, which has become sort of the global icon of large landscape conservation. And I used to talk about this as, concentrate your resources here. This is the last place where we can do this last great temperate system, and sort of a scarcity theory of value. And then something happened as I began to do more global work. People were interested in this idea, and I was in a nature reserve deep in the heart of India, Bandhavgarh National Park. And I had this encounter with this tiger. And it looked at me in my eyes, and I looked at it, and I thought, oh my God, this is every bit as cool as a grizzly bear. And it matters every bit as much. And it isn't right to say, just here, please. It needs to be everywhere. And I realized the way we need to think about Yellowstone to Yukon is as the first of the next, rather than the best of the last. And the core of the whole idea is protected areas, parks. The places we keep intact for nature are the basis of conservation, full stop, period. So how much of the world is in that condition? 15.4% of the world is now protected on land, 5% by sea. So how much do we need? What does nature need? This is the question. We're in a relationship with our home. What does nature need? Well, we can look at how nature is distributed right now in the world through what are called ecoregions. There's 846 of them. The one that I live in, the Rocky Mountains ecoregion is this one here, this kind of color here. But here we are in New England in a temperate Atlantic forest region and so on. The patterns of plants and species that live there and their interactions make up these 846 regions. So you can imagine, okay, well, what would it take to keep all of those systems alive and functioning? And about 15, 20 years ago, people started doing studies of ecoregional plans and said, to keep all of life going in one of these places, how much of it would you need to protect? This is a study from my region, Canadian Rockies, and it came out with you'd need to protect 49.7% of it. And by the way, we haven't taken into account species range shift and climate change, and we haven't addressed the connectivity questions, just the patterns of biodiversity. This is a roll-up of a bunch of those studies done in the United States by mostly the Nature Conservancy and experts associated with that, but also other scientists, for example, this one. And you can see a range from a low of 26% to a high of 70%. And the median is around half. This is a study from South Africa by a completely different group of people saying how much would it take to keep the Cape Floristic region growing. If you have a jade plant in your house, it came from here. It's one of the kingdoms of plants in the world that's unique. And the answer was 52%. This is by Indian scientists in the Western Ghat Mountains of India, below Bombay, the mountains that run down the west coast of India. How much of the Western Ghats would you need to protect in order to hang on to the things that live there? Answer, around 60% in an interconnected way. Then I started working with indigenous people, and their intuitive knowledge and their knowledge systems, which are based not only just on tradition, but on observation, as Janine said, they were coming up with land use plans to protect half of their traditional territory, or in this case, in the Peel watershed, more than 2/3, saying if we want to keep things alive, this is how we understand our place, that's the level. And then a couple of years ago, or about a year and a half ago, Ed Wilson came out with his book called Half Earth, where he used an idea called the species area curve, which is the idea that if you protected half the world, you'd save 80% of the species. It's a different way of getting at the same stuff. So about 8 years ago, we launched this idea called Nature Needs Half. And it's the idea that we need to protect and interconnect at least half the planet's land and water in an interconnected way in order to keep life functioning. And we really do want to keep life functioning because we're part of life. It's a pretty simple equation. So if you have an ambitious goal like nature needs half, how realistic is it? Well, the answer is it's very realistic. This is that same map of the world's 846 ecoregions. This is from a paper a number of us did in Bioscience last April. 12% of the Earth is already half protected. 64% of the world, it's feasible to do it still, with either just changing land use or with a little bit of restoration. 24% of the world is very challenging to do. So think of the Ganges River floodplain or the Sacramento area of California. It's very heavily transformed, and you can't reasonably expect to get to protecting half of that anytime soon. But 2/3 of the world, or 3/4 of the world, it's entirely feasible for us to do this. And we can start restoring the other parts. So how does that work? Well, this is a map of Canada, so where I'm from, but it's representative of many countries, as I'll explain. There are basically 3 conditions in the world. There's a heavily settled, heavily fragmented area. So this is southwestern Ontario, called Carolinian Forest. It's as transformed as just about any landscape you can imagine. There's the intermediate landscape where there's forestry and mining and oil and gas and logging and so on. And then there's the really, really wild part of the country, which also happens to run down that Yellowstone to Yukon corridor, as you can see popping out here in purple. The 3 conditions demand different conservation responses. The nature needs half idea is shorthand for think big and think that the extent that you're doing it at is far more than throwing a few bits at nature and being happy. This is China. Same conditions apply. You see how there's the big wild areas in Tibet, the green areas were the intermediate areas that you can weave together, and the very crowded areas. This applies to the United States of America as well. If you had a map of the US and you tacked on Alaska, you'd have the same thing. It applies to Brazil equally. And it even applies in the Indian subcontinent below the Himalayas. This is Bhutan. And Bhutan has a really interesting culture where they value nature. And they're kind of an animist, Buddhist culture, fascinating place. They have protected half their country in an interconnected way already. And it's real. I've been there twice in the last 2 years. It's all real. It's not paper, it's real. And they just decided to value nature, and that's in the Indian subcontinent. So there's really 3 conditions of the world: the big wild world, the large landscape, connect the pieces world, and then the endangered species, try to restore it world, where the crowded 25% lives. But if you go to the Amazon, for example, the Amazon is already half protected between about 1/4 in parks and another quarter in indigenous protected areas that maintain forest cover. And you say, well, is that enough? And actually, it's not enough in the Amazon. Because we have to think also not only of patterns of nature, but natural processes. So the climate and climate change and things like that are all processes that affect us. Natural processes are also driven by the living layer of the earth. So in the Amazon, the first rainfall comes from the ocean just like you would expect it to everywhere. It comes, it precipitates, it drops, there's a band of rainfall. But then something amazing happens. The forest takes over, and the forest drives the rain. So here you see, I took this from the top of an observation tower in the heart of the Amazon, and you can see the clouds of vapor rising. Well, these trees are also releasing organic matter that seeds the water vapor, and then it falls again as rain. So the next rainfall is driven by the forest, and then that forest drives another rainfall, and another, and another, until it hits the back of the Andes. You take out the forest, and the estimates are somewhere between 70 and 80% of the forest must remain standing, or it will stop raining in the Amazon. In other words, lose 20% or more of the forest, it stops raining. If it stops raining in the Amazon, in the abundance that it has now with the warm climate there, it flips to a savanna. If it flips to a savanna, the rainfall in the interior of the United States agricultural areas declines. This is a global phenomenon driven by nature. And so, we heard about the World Scientist Warning this morning. It was a redux of the 25-year-old one led by Henry Kendall, which was all the 200 Nobel Prize winners saying, we're in trouble. Well, today 15,000 people signed something saying, we're really in trouble. And this is from the climate change report that Bill Muma helped to author. Fundamentally, we're going to overwhelm ecosystems this century through these combined effects that the Admiral talked about. The synergistic effect of things is going to overwhelm nature. Now, is that stupid or what? We don't have to do this. We can save nature at scale. We can protect at least half the world. And we can start turning this around. And we have to live, though, as this is home. We have to recognize we're in a relationship with nature. And that no relationship works when you're just exploitive. And our species right now is just exploitive. Where's the reciprocity in our behavior? So that's the idea behind nature needs half. The idea of protecting and interconnecting at least half the world in an interconnected way. I kind of think of it as Yellowstone to Yukon goes global. And I want to leave you with an abstract thought. What's this? So that's the founding of Western civilization, right? Rome. So look at the image for a moment. What you see is humans being suckled by wild nature. This is actually an Etruscan bronze. Through the Roman period, we forgot that we depend on nature. We thought we were masters of it. We developed aqueducts. We developed these straight roads. We developed the idea that we're lords and masters of the universe. And the Romans actually conquered indigenous people like the Druids by cutting down their trees and saying, no, you are subservient to this. Indigenous people all over the world still remember this relationship. And places like India, where in the culture still there's a lot of understanding that we're part of nature. This is normal. Our last 2,000 years of civilization where we went bonkers and thought the earth was there to serve us is actually a blip, an anomaly in human history. If we get back to this, my time is up, so that's good. Because this is where we need to get back to. Nature nurtures us. We need to protect at least half the world, and we can do this. This is not a fantasy. This is a dream, and humans need dreams. Thank you.